All right, welcome back to Mr. PL's with Algebra 2. This is Unit 2, Topic 3, SLT24. So we are now changing rational functions from what I like to call asymptote form into standard form. It's kind of like changing mixed fractions, which is the reason why we have this for our warm-up. So if you take mixed numbers and you change them to improper fractions, it's going to be the exact same process. So you were told that you take the denominator, multiply it by the whole number, and then add it to the numerator to change a mixed number into an improper fraction, a fraction where the numerator is bigger than the denominator. 3 times 1 is 3, plus 2 makes 5, so that's 5/3. 4 times 3 is 12, 12 plus 1 makes 13/4. And 11 times 2 is 22, plus the 6 on top makes 28/11. Now, what about when we're going backwards? We want to turn an improper fraction back into a mixed number. So then we divide. We ask ourselves, how many times can 3 go into 13? So you're really doing 13 divided by 3. And 3 times 4 is 12, and that leaves you with 1 left over. So that's the same as 4 and 1/3, because 4 full times and 1 is the remainder. 1 is how much is left over out of 3 that it takes to make 1 more whole. So I'll do the same thing here. So 7 divided by 2, 2 times 3 is 6. Subtract, you're left with 1 left over. So it's -3, because a negative divided by positive is a negative, with 1 left over out of 2 that it takes to complete a whole. 12 goes into 25 2 full times, because 2 times 12 is 24. Take away 24 from 25, and you're left with 1 left over. So 25/12 is really 2 and 1/12 if you change it to a mixed number. Now, how does this apply to rational functions? Because it's going to work just the same. It's the same process. According to what we learned about transformations, what we learned, okay, so this is basically the same as. So this graph right here is the same thing as what we had learned in a couple videos ago, which is right 5 up 2. So if it's right 5, it must be x minus 5, and then it's plus 2 because of the up 2, and the next term looks to be about 1 above. So we now know that if this graph matches this equation, then it also matches this equation because of what we had learned in the past. Now that's the exact same thing. You can always take the last number and put it on the front, and it's going to be the exact same thing, because 2 plus this or this plus 2, it's commutative property of addition. It doesn't really matter which way you're adding them. So that means that these two fractions are exactly the same. So this is kind of like a mixed number, and this is kind of like an improper fraction. So I call this asymptote form. The reason why I call it asymptote form is because the two numbers given are the asymptotes. This is the vertical asymptote, which means it meant right 5, and this is the horizontal asymptote because it translated up 2. All right, that's kind of the same as we had just talked about. So this is the process. It's the exact same process it was for mixed numbers to an improper fraction. So you're going to multiply the denominator by the whole number. You're going to add the numerator, and then you're going to put it over the original denominator. So I'm going to do 3 times x minus 2. That's the whole number times the denominator, and that's going to give me 3x minus 6 when I distribute the 3 to both terms. And then I'm going to add the numerator, and that gives me 3x minus 5, because -6 plus 1 is -5. And then I can just take that and put that expression over the original denominator. So that's 3x minus 5 over x minus 2 was the original denominator, and voila. I've now just turned this asymptote form into this standard form. All right, so what transformations do we have here? So it's right 2 up 3, right 2, 1, 2, 3. So there's the new origin. And then I can draw my two asymptotes from that point. And it does also tell me that the next number is going to be 1 above. So that's what the graph's going to look like. Which means that the next number is 1 above, then the previous number is going to be 1 below, and it's going to look just like this. Now, I know I've been rushing it, so it's going to be a little bit sloppy here, but that gives you a basic idea of what it's going to look like. Now, what will this be in its new form? And the reason why it is what it is because 3 times x minus 2 and plus add the 1 on top, as we just figured out in the last equation right here, as I had solved for it already. That's the exact same thing. Now, you can't tell the asymptotes from standard form, which is the reason why I call this asymptote form, because it tells you the two asymptotes. This does not. So this is not as helpful when graphing. But this might be helpful when putting it to the graphing calculator. But if you're going to do that, you have to put both the numerator and the denominators in parentheses. Otherwise, only sees the two middle terms as the ones being divided. So please be careful when you're putting this in the graphing calculator. Just make sure you put both the numerator and the denominator so that it knows that all of the numerator is being divided by all of the denominator. All right, so you try converting them, it says. I'm going to do 1 times x minus 4, and that gives me x minus 4, because 1 times anything is itself, and then add the numerator, and that gives me x minus 1, because negative 4 plus 3 is negative 1. So therefore, my answer is x minus 1 over x minus 4. Now keep in mind, this is an improper fraction, because x minus 1 is going to be a bigger number than a number minus 4. Because when you take away a bigger amount, you're going to make that amount smaller. The next one, negative 5 times x plus 3 is going to give me negative 5x minus 15. Add the numerator to it, and I get negative 5x minus 14. And there's my answer, negative 5x minus 14 over x plus 3. And it looks like I'm going to have to clear this out in order to do the last one. And the last one's going to be 2 times. Okay, now this negative, we haven't talked about this. It'd be easier if I put that negative up top. Now, you could put it down below, but then I would have to distribute that negative to the x and the 7. That's just going to be a little bit more work. So you can't put it on both, because a negative divided by a negative would be a positive, not a negative. And a minus sign is basically the exact same thing as a negative. So I changed it, I moved the negative up here and then changed this to a plus. So this is really 2 times x plus 7, which gives me 2x plus 14, and then add the numerator, and I get 2x plus 10. And there's my answer, 2x plus 10 over x plus 7. Now, you can always use a graphing calculator, check it. If you want to make sure, put this into your calculator in f of 1, and then put this graph in f of 2, and then you'll see that they are the exact same graph when you press graph. All right, so how about when we go backwards? What if we want to change an improper fraction back to a mixed number? So remember, we divided. We did 38 divided by 15, and we said, well, it goes in 2 full times, because 2 times 15 is 30. That leaves me with 8 left over. So that was 2 8/15. So the answer ends up being the whole number, and the remainder ends up being the numerator, and the denominator stays the same. Well, that's going to be the exact same thing when we convert our standard form into asymptote form. So I'm going to divide. I'm going to do 5x minus 7 divided by x minus 2. And I'm going to look just at the first terms. I'm going to say, what would I have to multiply x by to make it 5x? And that's 5. 5 times x is 5x. 5 times negative 2 is negative 10. And then I'm going to subtract those two numbers. Now I like to put this in parentheses just so that it keeps it separate from the negative sign. 5 minus 5x makes nothing, and negative 7 minus negative 10 is 3. So your answer is 5 plus, because it's positive 3 over x minus 2. There's your answer. All right, so for number 2, I'm going to change colors here. So that's going to be 2x plus 9 over x plus 3. What do I have to multiply x by to make it 2x? That's 2. 2 times x is 2x. 2 times 3 is 6. Subtract them, and 2x minus 2x is nothing. 9 minus 6 makes 3. So that gives me my answer. So it's going to be 2 and 3, positive 3 over the original denominator, which was x plus 3. Now, I do know the two asymptotes, because remember, this is the vertical asymptote, so the vertical asymptote is going to be x equals negative 3, and the horizontal asymptote is going to be y equals 2. Y equals 2. This is always the horizontal asymptote. This is always going to be the vertical asymptote. And I would graph it, but you can just see that from a prior video. All right, and I think this is my last, yes it is, my last slide. So a couple more examples. So that's x plus 5 divided by x plus 3. I would have to multiply x times 1 to make x, and 3 times 1 is 3. Subtract, I get 2 left over, so there's my answer. 1 plus 2 over x plus 3. Vertical asymptote right here at x equals negative 3. Remember, it's always the opposite. And horizontal asymptote of y equals 1. And last one, 8x minus 15 divided by x plus 6. Sorry, that should have been straight up and down. It's not a square root. So x times 8 is 8x. 6 times 8 is 48. Subtract the 2. Negative 15 minus 48 more makes negative 63, I believe. So that's going to be 8 minus 63 over x plus 6. Now, you could have also written that could have been negative 63 over x plus 6 plus 8. That would be the exact same thing. There's actually several ways you could write this exact same expression. Because like I said, remember, you can move this minus sign up to the numerator, or you can move it down to the denominator. And then this, you always take the sign that comes before something. And since there is no sign, this is really a positive 8. Now, it doesn't matter if you put the positive 8 on the left-hand side or the right-hand side. It's going to be the exact same thing. All right, thanks again for watching. Please give it a like to help you learn something about how to change asymptote form into standard form. And watch out for the next videos. Thanks again.